My name is Dennis Solano. Today I'm going to give a presentation about what is a quark. So basically, when we were kids, we were told that everything was made of atoms, and that atoms were the small particle. And then we were told that an atom is made of smaller particles, which is an electron, neutrons, and a protons. Which this means that that was it. But then we came with this, that what is a quark? So today I'm going to try to teach you what's quark and give you a basic idea of what is it. So then we go to a quark. So quark is an elementary and fundamental particle, which means they cannot be split into smaller particles. So then we got the quarks combined to form composite particles called hadrons. So a hadron is a composite particle held together by strong forces and as molecules. And some examples are protons and neutrons. So quarks are never directly found by itself or by in isolation. They always have another particle. Basically, you have a quark and an antiquark. Then we're going to teach you what types of quarks are and what are their characteristics. Now, the quarks have several intrinsic properties, which are charge, spin, color, mass, and another type of characteristics. Then we go to more specific information about a quark. So quark is a composition is an elementary particle, and his statistics are fermionic. So this means that this is a fermionic particle, which in physics, it behaves or has the characteristic that fermionic particles should have. Keep in mind that, if you want to know what is a fermionic particle, you should Google it up. Then we have the generations. We have first, second, and third generation. Again, this is a physics term. And then we have the interactions, which the interactions are electromagnetism, gravitation, stroke, and weak interactions. Then the symbol for quark is Q, and the symbol for antiquark is Q with a small line on top. Then when was it first? It was first theorized by Murray and by George Swain. They say in 1964 that neutrons and protons were made of smaller particles, but people didn't believe, how if they're so small, how they're made of even smaller particles. So until 1968, they found out that the neutrons and protons are made of smaller particles. In the SLAC in 1968, there are 6 types of quarks, and every single quark has an antiquark. So we have the up, the down, the top, the bottom, the strange, and the charm quark. So again, there are 6 types of quarks, and they have 6 antiquarks, and they have different characteristics by itself. The electric charge of there are 2 types of charge. So 3 types of quarks have 2/3 of charge, and then the other 3 charge. The 3 quarks have 1/3, nearly 1/3 charge. They have a color charge, and they have a spin. So basically, we have 3 types of colors, and just these 3, which are blue, red, and green. So this is a quark. This is a proton, and these are 3 valence quarks. So they have more, or they might have more. And also, you say why protons don't have colors? But because we have 3 colors. But the truth is that when you combine all these 3 colors, you get white. So that's very cool. Yes, and the proton is made of 2 positive quarks and 1 down quark. Then again, in 1969, they have made several experiments to try to understand more, or try to find more information or more particles. But they come everything to the same conclusion, that was found before, that that they are composed of 2 up quarks and 1 down quark. Next, we have a photo of what are proton and a neutron. So a proton has +1 charge. But why? Well, because you have 2 up quarks, which 2/3 plus 2/3 minus 1/3 of the down quark, you get 1. A neutron has 2 down quarks and 1 up. So when you have 2/3 minus 1/3 minus 1/3, you get 0. So this is why they have a +1 and a 0 charge. Now you know. Also, protons, could have more particles. As I said before, they are made of 3 valence quarks, but they might have more quarks. But the rule is that they have to have 2 plus or 2 more up quarks than than anti-down quarks, that anti-up quarks. And then the other rule is they have to have plus 1 down quark than negative anti-down quark. And also these particles, these protons could have more quarks, which is they could have pairs of strange quarks, pairs of chunk quarks. But they don't count because, as we say, they counter. So you have an anti-quark plus a number of quarks. So an anti-quark has the same characteristic but in negative. So at the end of the day, they cancel out. Also, there is a particle called gluon. So these particles held together the quarks. Keep in mind that, as I said, protons are colorless. Again, the history of how they were discovered. So at the time of the quark theory inception, it was called the particle soup, and included, amongst other particles, a multitude of hadrons, which, again, they found out the hadrons are made of quarks. So here we have a photo of Murray and a photo of George Swing, which are, they theorized about quarks. So here we have a photo of the type of quarks. Here we have a more detailed photo which shows you that the top quarks have a charge of 2/3 positive, the chunk quark have a charge of 2/3 positive, the up quarks have a charge of 2/3 positive, the down quark has a charge of negative 1/3, the strange quark has a charge of negative 1/3, and the bottom quark has a charge of 1/3. Keep in mind that these quarks have antiquarks. Again, as I explained, the antiquark is a quark but with the opposite characteristics. Here we have a chart showing us how they were discovered. As we can see, they are fairly recent. The last one was the top quark, found in 1995. And these quarks were found by basically colliding electrons with electrons, colliding protons with protons. And this is how they discovered these quarks. So here we're going to see another characteristic, which is the generation of quarks. So we have 1, 2nd, 3rd generation. Again, this is physics characteristics, which show us that, depending on the mass, the size, the spin, you can divide into different types of quarks. So then again, the first quark generation is the down and the up, the second generation is the strange, the charm, the third generation is the bottom quark, and the top quark. And we can see, 3 quarks have 1/3 charge, and 3 quarks have 2/3 charge. Then we have the properties of quarks, more properties. They have many properties. Then we have again the electric charge, the spin, the weak interaction, the strong interaction, and the mass. Again, the electric charge, we showed that 3 quarks have 3 different types of charge. 3 quarks have a positive charge, and 3 quarks have a negative charge. And as I said, antiquarks have the opposite charge to the corresponding quarks. The spin is an intrinsic characteristic of elemental particle, which basically tells us that its direction is an important degree of freedom. And the spin value of a quark can be 1 plus, 1.5 plus, or 1.5 negative. We have the weak interaction, and the weak interaction tells us that a quark, an up quark, can be transformed into a down quark. So this is very complicated, which basically, how does it change from one type of quark to another quark? By absorbing or emitting W bosons. Any up-type quark, up-charge, or top quark can change into any down-type quark, and vice versa. And this shows you, what is the process and how this changes. It's very complicated, and you really have to like physics to try to understand, or to really try to understand physics first, the characteristics to come and understand this. Then we have the strong interaction and the color charge. This means that the quarks can also change colors. And also, a quark has a color of a quark has an anti-color of a quark. So which means that we have green, red, and blue. We have anti-green, anti-red, and anti-blue. As you can see, they make the green and the anti-green have opposite directions. Same with the red and the anti-red, the blue and the anti-blue, the green and the anti-green. You can see in the middle we have white. And then the next characteristic, which is mass. So mass is divided into type of mass. A mass which is called the current quark mass, which is the exact value of the mass, and then of the mass, just the mass of the quark. And then we have the constituent quark mass, which is the mass plus the gluons. I would say gluons are particles that help together quarks. But they're very, very small and they don't really count. So as I said, just to finish, the advantage of quark, as I said, the gluons only exist to hold quarks. So they're very small, so maybe we don't take into consideration. So it's one less problem. And also the quark, gluon, neutrinos, and also other things are much smaller than protons and electrons. That's it. Thank you.